Let's symbolize statements 1 to 8 using predicate logic. So I've got two, in my symbolization key, I've got two names. K and D are mean the king and the duke. And I've got three predicates. And these are things that if I put a variable or a name in there, then they will create a statement once we sort of fill in the blank with a variable or a name. So number 1 says the king is in danger. And I don't actually have a predicate for being in danger, but for the purposes of this exercise, I'm going to interpret being not safe as being in danger. And who is not safe? It's the king. Number 2 says the king and the duke are not in the castle. So I've got the king is not in the castle. Sorry. The king is in the castle, but he's not. And the duke as well is not in the castle. Number 3 says, if the duke is in the throne room, he's in the castle. Now, who's he over here? Well, he is also referring to the duke. So if the duke is in the throne room, so being in the throne room is the duke. If the duke is in the throne room, then he's in the castle. Then the duke is in the castle. Number 4 says, everyone is in the castle. So this is where we start needing our quantifiers, because when we say everyone, well, that's neither of everyone doesn't mean the king and everyone doesn't mean the duke. So we're going to need some quantifiers, and we've got two. We've got the universal quantifier and secondly the existential quantifier. And one way of reading these is the universal quantifier can be read as for all, and the existential quantifier can be read as for some, or there exists. And so if I say for all x, that means that for all x, what follows, the proposition that follows, is true of x. And if I say for some x, that means that for some x, for at least one x, what follows is true of that x, or there exists at least one x for which the following proposition is true. So if I've got number 4, and I'm saying everyone is in the castle, to rephrase this using for all, I can say for all x, x is in the castle. For all x's that there are, they'll be in the castle. Number 5 says, no one is safe. So one way to say this would be, for all x, x is not safe. So everyone is not safe. For all x, it's not the case that x is safe. And there's this property of existential and universal quantifiers, which is that they're duals of each other. And that means that we can always express one in terms of the other with some specially placed negations. And I encourage you to look in the textbook to figure out the exact precise relationship of where you put the negation. But we can sort of do it intuitively here. So how would I express no one is safe using the existential quantifier instead? Well, I could say there does not exist anyone who is safe. Number 6 says, the king is in the castle, but not in the throne room. So the king is in the castle would be, the king is in the castle, but not in the throne room. So who's not in the throne room? Is it some random person? Do I need a quantifier? No, in the sentence it's actually talking about the king again. So the king is not in the throne room. All right. Number 7 says, everyone is safe if the king is in the castle. So if the king is in the castle, then everyone is safe. If the king is in the castle, then everyone is safe. For all x, x is safe. And what's an alternative way to write this using an existential quantifier instead? Well, if I wanted to use an existential quantifier, I could say anyone who's in, sorry, I'm trying to express everyone is safe. So I could say, another way of saying everyone is safe is saying there's no one who's unsafe. So there does not exist any x where x is not safe. So that's an alternative way to express that. Number 8 says anyone who's in the throne room is safe. So I can express this using a for all. For all x, if x is in the throne room, then x is safe. If x is in the throne room, then x is safe. And how would I express this one using an existential quantifier? Well, if anyone who's in the throne room is safe, then no one who's in the throne room is unsafe. Then there does not exist anyone in the throne room who's unsafe. So I'd say there doesn't exist anyone who is in the throne room and is unsafe, who's in the throne room and is not safe. And another way of writing this is there does not exist an x for whom, if they're in the throne room, they're unsafe. Sorry, if they're in the throne room. So that's not the case that if they're in the throne room, they're safe.